Hey guys, it's Miss Hippenmeyer again, and in the second video, we're going to be comparing decimal values using inequalities. Let's first recall our place value. So I want you to focus on the left side of the decimal and just read through these places. So the 7 is in the ones place, the 6 is in the tens place, then it goes hundreds, thousands, 10,000s, 100,000s, millions. Now, I want you to notice how this side mirrors this side of the decimal. So we have tens over here, and then over here it starts with the tenths place. Hundreds, and then over here we have hundredths. Thousands, thousandths. 10,000s, 10,000s. 100,000s, 100,000s, and then 100,000s. Millions, and then millions. So hopefully that was a good little refresher. And let me go on to the next slide. All right, now we're comparing 9/10ths to 8/10ths. And I want you to think about what a tenth is. So I want you to think about a circle being broken up into 10 pieces. And when you think about 9/10ths, that means that you have 9 1/10 slices. And then over here, 8/10ths means that you have 8 of these 1/10 size pieces. So you have more of the same size pieces over here than you have over here. So 9/10ths is greater than 8/10ths. You can also plot these two and see that 9/10ths is further to the right on the number line, which means that it's larger than the 8/10ths. Now let's look at the next example. Okay, so this gets a little bit tricky. Think about it this way. Okay, we have more slices, right? So that means if there are more slices, it is more or further to the left. And the further to the left you go on the number line, the smaller the numbers become. So negative 9/10ths is actually less than negative 8/10ths. It's further to the left of 0. Next example. Now we're not comparing the same size pieces. We are comparing 5/10ths to 5/100ths. So divide a pie into 10 pieces and divide a pie into 100 pieces. And then let's do a quick comparison using a highlighter. So I'm going to highlight 1, 2, 3, 4, 5 pieces. Okay, so that's half. That's half of this circle is 5/10ths. Now over here, 5/100ths is 100, 200s, 300s, 400s, 500s. I tried to do my best at coloring 500s. So you can see that this is much smaller than this, or you could say that 5/10ths is greater than 5/100ths. Okay, here's another way to compare these two. A little trick is to just say, all right, well, I know that this is the hundredths place because I have two numbers to the right of the decimal. Well, over here, what I can do is I can say, well, I don't have two places to the right of the decimal, but I could add a 0 because 5/10ths is the same as 50 hundredths. 0.5 is the same as 0.50. Now by doing this, do you see that I have two decimal places here and two decimal places here? So now I'm comparing 50 hundredths to 5 hundredths. So now we're comparing the same size pieces, which makes this easier. Now 50 hundredths, think about 50 out of 100, that's half. Okay, so it still represents the same thing that I colored in before, and this still represents 5 of those little slices, 1, 2, 3, 4, 5, but it's just a different way to compare it, both in hundredths. So let's go ahead, let me switch to a pen, and then we need to show that if you have 50 hundredths, that's more than 5, so we're comparing 50 to 5, and that is greater. 50 hundredths is greater than 5 hundredths. Let's go ahead and go to the next example. Okay, now we're comparing this in negative form. So I want to start by using my trick and adding a 0, and now we're comparing basically negative 50 hundredths to 5 hundredths. So I'm going to put a little negative sign in front of what I wrote. So negative 50 hundredths compared to negative 5 hundredths. And think about it like this on a number line. If this is where 0 is, this is 50 hundredths, so it's further to the left. So 50 hundredths would be further to the left than 5 hundredths. 5 hundredths is not much past 0, but 50 hundredths is more past 0. So this value is smaller. It's less than. So 50 hundredths is less than 5 hundredths because it's further to the left on the horizontal number line. All right, our next example, let's use the same trick. So we have two numbers past this decimal, so I need two numbers past this decimal. Okay, the 2, that doesn't help that comparison. They both have a 2. But now we can compare 18 to 30. We have 18 hundredths and 30 hundredths. So think about hundredths, okay? 30 hundredths is more than 18 hundredths. So 2 and 18 hundredths is less than having 2 and 30 hundredths. So 2 and 18 hundredths is less than 2 and 30 hundredths. All right, now we have 3 numbers, 1, 2, 3. So what I need to do is have 1, 2, 3 over here, so I'm going to add a 0. That was kind of messy. Let me erase that. So I just want to show you that we're adding a number here so that we can compare 5 and 83 thousandths to 5 and 70 thousandths. So we're really comparing that 83 to that 70, and that is a greater amount. 5 and 83 thousandths is a greater amount than only 5 and 70 thousandths. Okay, now we're comparing negatives, which can seem more confusing, but use the same model. I'm going to add a 0 so that I'm comparing, this is the, okay, goes tenths, then hundredths. I'm comparing 20 hundredths to 6 hundredths. Well, really 18 and 20 hundredths compared to 18 and 6 hundredths. So there's more of this. Right now I'm ignoring the negative sign, okay? So there's more, 20 is larger than 6, but now I need to think about it in terms of negative values. So I want you to think about how negative 18 and 20 hundredths is more to the left. Since there's more, 20 is more than 6, so it's more to the left, further to the left than negative 18, and only 6 hundredths. So if it's further to the left, it's actually smaller, or you could say 18 and 20 hundredths is less than negative 18 and 6 hundredths. All right. This is our final example. I'm going to add a 0 to this side, and I hope you notice that these are the exact same number. So we're comparing negative 6 and 70 hundredths to negative 6 and 70 hundredths. So we just put an equal sign. These two are equal.